I'm Jess from Soundwaters. We're going to talk all about the greenhouse effect today. Earth's climate is driven by the sun. Solar energy powers photosynthesis, powers evaporation, and it's absorbed by the heat and the land, keeping us warm on Earth. Now, the Earth is a sphere, so it's not heated the same in every location. The equator is heated much more greatly than the poles. So it's up to the atmosphere and the ocean to move all of the heat around through ocean circulation, through rainfall patterns, and things like that. A lot of heat energy is coming into Earth's system. According to NASA, 29% is immediately reflected by the upper edge of the atmosphere right back out into space. 48% is absorbed by the land and the oceans, and the remaining 23% is absorbed by the atmosphere. Now, in a perfect world, the amount of energy coming into Earth's system would equal the amount going out, so we remain at a constant temperature. This isn't the case. We know that Earth's climate is warming, mostly due to effects of humans. By emitting greenhouse gases into the atmosphere, we're amplifying something called the greenhouse effect. Greenhouse gases have been given a bad rep, but they're really important to maintaining the temperature of Earth. Without greenhouse gases, the entire Earth would be a giant ball of ice, be a chilly 0 degrees Fahrenheit or negative 18 degrees Celsius. Thanks to these greenhouse gases for trapping some of the heat near our Earth's surface, the average temperature of Earth is around 59 degrees Fahrenheit or 15 degrees Celsius. Now, with all of the extra greenhouse gases we're emitting into the atmosphere, we are amplifying the greenhouse effect. Let's go dive a little bit deeper into this greenhouse effect now.
The sun emits energy toward the Earth in the form of electromagnetic radiation. So this radiation is actually waves entering the atmosphere, and they're short, high-energy waves. They're visible as light. So this is what we feel when we feel the sun's heat. Now, as we mentioned earlier, some of these waves are immediately reflected back out into space. But most of the energy is absorbed by the land and the ocean on Earth's surface. And the energy that's absorbed by the surface of Earth is radiated back out into the lower atmosphere as heat in the form of thermal infrared radiation. So this radiation is also waves, but they're a much longer wavelength than the incoming solar energy. Now, if there were no greenhouse gases in the atmosphere, the heat radiated from Earth would escape to space, carrying all the absorbed solar energy back out of the system. And this would cause Earth to become a gigantic ball of ice. Now, thankfully, we have greenhouse gases in the atmosphere that acts kind of like a blanket. They trap some of the heat radiated from Earth by absorbing and redirecting the heat energy back down, and they keep it near Earth's surface. Some of the heat is also passed around from gas molecule to gas molecule. So in a perfect world, the amount of energy coming in from the sun would equal the amount of energy going back out into space. Now, unfortunately, we have increased the amount of greenhouse gases in the atmosphere, which has amplified the Earth's natural greenhouse effect, pretty much like putting on a thicker blanket. And this causes the temperature of the Earth and the lower atmosphere to rise.
A lot of gases make up the Earth's atmosphere. Greenhouse gases such as methane, nitrous oxide, water vapor, and carbon dioxide only make up a small portion of those gases. 99% of the atmosphere is made up of oxygen molecules, so O2, and nitrogen molecules, or N2. Now, these molecules are each made up of 2 oxygens, or 2 nitrogens, connected by 1 bond. So when they get hit by the energy from the sun, the molecules, the atoms, start to vibrate. They get a lot of energy, but they don't really have much space to move. So they end up decelerating or losing their energy very quickly. They can't heat up very much. So they aren't very much contributing to the heating of the Earth. But carbon dioxide, which is one of the most talked about greenhouse gases, is very good at heating up. There are 2 oxygen molecules connected to 1 carbon molecule. This gives them a lot more space to move, a lot more energy they can collect. So they can help to radiate the heat from coming in from the sun back down to the Earth. They also can trap some of the heat being radiated from the Earth into the atmosphere. So they kind of work like little heat lamps heating up the Earth's surface. The most prominent greenhouse gas in the atmosphere is water vapor. Now, if we compare the structure of water vapor to the structure of the carbon dioxide molecule, they're pretty different. The water vapor is in a bent shape, so it's kind of like a triangle with the 2 hydrogens below the oxygen. The carbon dioxide molecule is in a straight line. So these atoms can only move in so many directions when they heat up, when they get warm. This water molecule has a much more variety. It can move in many more directions than the carbon dioxide molecule, so it's better at absorbing the heat, energy. And the interesting thing is that water molecules can absorb only certain wavelengths of energy. So certain things that would be coming from the Earth back out into the atmosphere aren't stopped by this guy. But the carbon dioxide molecule can absorb the radiation, that the water molecule cannot. So the energy that would normally be passed right through this into the atmosphere, right all the way out into space, are being caught by the carbon dioxide molecule, which is increasing the temperature of the atmosphere. Even though greenhouse gases do come from natural processes, the excess of them is due to human activity. And the excess in the atmosphere is causing the Earth's temperature to warm. Between 1880 and 1980, every decade, there is seen an increase of 0.13 degrees Fahrenheit in temperature. Now, from 1981 until present, that rate of increase has gone up, and 0.32 degrees Fahrenheit is now the global average increase each decade. That's a lot warmer. And the extra warmth in the atmosphere is having repercussions on the Earth's systems, and repercussions around Long Island Sound. One of them being ocean warming. All of the extra heat in the atmosphere, a lot of it's being absorbed by the ocean. This is causing species diversity to change, distribution of species to change, and it can even mess up the circulation of the ocean a little bit as well. And paired with ocean warming is sea level rise. Sea level rise is due to ice melting on the continents, and also due to the thermal expansion of the water as it warms. And the ocean is also becoming more acidic. The extra carbon dioxide in the atmosphere is being absorbed by the ocean as well. And the absorption of CO2 into the ocean is causing it to become more acidic, which can have repercussions for different animals that live in the ocean. So how can we help to make a change to help reduce the rate of climate change? Carbon dioxide is the leading cause of climate change in the atmosphere. So if we help to reduce our carbon emissions, that'll help to slow the rate. There are a few simple things we can do to do just that. One of them is to carpool. It's the easiest one. If you're going somewhere with your friends, just drive together. You could help save 4.6 metric tons of carbon from going into the atmosphere by not driving alone. Another thing we can do at home is to add solar panels to our house. Alternative energy is a great way to reduce carbon emissions. Solar panels can produce almost all the energy that your home needs to survive throughout the year. You can also compost at home. Composting helps to remove methane from the atmosphere. Every year, 12% of the world's total methane comes from landfills. And methane is a more powerful greenhouse gas than water vapor or carbon dioxide, so it's not great if there's a lot of it in the atmosphere. It's very important that we as a society do everything in our power to reduce our carbon emissions and slow the rate of climate change.